Okay, hello everyone. So let me show you how to use the formula to solve a differential equation using reduction of order method, and it's very easy. But one thing important you have to write down in your notes, that if you're going to use formula, you have to have your differential equation in standard form. But if you're using the general approach, you don't have to. Okay, but here we need the standard form, so we have to divide the differential equation by x, the whole equation by x, to make sure we have 1 as the coefficient of y double prime. So if you divide by x and assuming x is equal to not 0, we get y double prime minus 1 plus x over x y prime plus y over x equal to 0. So this is the standard form. Now if you want to use the formula, if you can look at the formula, it's just you need to substitute whatever you know to this formula. All you need is p and y1 if you carefully look at the formula. So formula is y2 y1, let's write it down, e to the negative integral of p over y1 square. Alright, so what is p here? P is the coefficient of y prime, which is 1 plus x over x. Now don't forget that negative, okay? You have to count that negative too. So I can write this in a different way to make my life easy. Specifically distributing negative and dividing each term by x, I get negative 1 over x minus 1. So let's substitute now all this information into the formula. So y2 is, y1 is e to the x, y1 square is e to the x square, and e to the negative integral of negative 1 over x minus 1 dx. Now you can see, when you use the formula, you don't find u explicitly. What is u? We say y2 is u times y1, right? Unknown function u. So what you're really targeting is to find that u. That is for general approach. But when you use the formula, that's already done for you. Okay, so there's a lot of proof. We saw it. And when you're using the formula, you don't find u explicitly. Okay, rather you get the second solution directly using the formula. Okay, so now how do we work on this intimidating formula? Well, the first thing you should do really is, you have two integrals. You should focus on the little integral that involves p. That's the first thing you have to do. And you know what? You have a y1 outside the integral, outside the big integrals. Don't even touch it. Do not look at it. No. Don't take it inside to the bigger integral. Do not do that. We will deal with that term on the very last step, where there's no integral involved. Okay, so don't even touch this. Let him be like that. Okay, e to the x. Now integrate the top. So anyway, before integrating, we can turn this all into positive, because when you multiply through this outside negative, everything becomes positive. So don't drop this e. If you integrate 1 over x, you get natural log x. If you integrate 1, you get x. Do not forget this base e, okay? E to the x square. Alright, so get done with that integral on the top. Integral involves the p. Good. And one thing, in case you didn't notice, finding p correctly is very important. So don't forget to put the differential equation in standard form, okay? Wrong p, wrong answer. If you get this question in the exam, you will be doing this forever if you use the wrong p, okay? All right. So now, well, once you do that small integration, you get this e term simplified. That should be the next step if you're using the formula. How can we simplify? Well, we can break this term up by writing e to the ln x, e to the x. Okay? All right. Now, what are you going to do? Now, simplify furthermore. See whether you can simplify terms, cancel some terms. Well, yes, e to the x and 1 e to the x cancel out, right? So what's left? E to the x, e to the ln x over e to the x, right? Okay, now you can see, even though the formula looks intimidating, really things get simplified out, okay? Alright, so what is e to the natural log x? We know logarithmic properties, and that's x. So this is x over e to the x. Good. Now the final touch, I'm going to rewrite this integral as x. I will take this term to the numerator and write it as e to the negative x. Good. to make my life easy, to make my integration easy. Now you can see this has come down to a smaller formula. Okay, good. Now, are we taking this ex to the inside? No. Okay, don't even look at that term. No. Okay, so first do this integration. All right, then let's deal with that outside term. So how do you do this integration? Well, let's take it separately. Let's forget about this e to the x for a second. X times e to the negative x. How do you integrate this? Well, we have to use integration by parts. Okay, so here I'm going to choose my u to be x, dv to be e to the negative x. So then du over dx will be 1. So that means du is dx. Now you integrate dv to get v. Well, I differentiated here. Okay, here if I integrated dv to get v, we get negative e to the negative x. So the formula is uv minus integral of v du. U is x, v is negative e to the negative x minus negative e to the negative x dx. Okay, du is dx. So if you integrate this, negative x e to the negative x, this is plus. If you integrate it to negative x, you get another negative plus c. Okay, so this is this integral. Now here you get to choose your own constant. So let me choose my c to be 0. Then we don't have extra term, right? So let's choose it to be 0. No harm is done. All right, so then really the integral is this term. Okay, so we can write ex times, so this term is negative x e to the negative x minus e to the negative x. Well, let's simplify this now. Now see, you have done with all the integrations. Now deal with what you have outside that integral, the y1 term. So if you distribute, you get negative x e to the x times e to the negative x. What should you get? Well, you have to add the exponents, right? X plus negative x is 0. E to the 0 is 1. Okay, so this term is 1 times x minus this is also 1, right? E to the x times e to the negative x is 1. All right, this is y2. Okay, so here's your y2, negative x minus 1. So y1 was e to the x. So final solution is general solution c1 e to the x plus c2 negative x minus 1, where c1 and c2 are arbitrary constants. So that's the general solution. Okay, that is how we use the formula. And see you in some more example videos. Okay, thank you.